Hello friends, welcome to Studybay Technologies, and in our today's session we are going to discuss about the paper that's held today. Now, in the first question it was given that we have to check a couple of numbers without actually solving them, that whether they are terminating or not. Right, so the first question was 3 upon 45. So in that case, what we have to do is like we have to check the denominator, that is 45. We can find out the factors of this. These are 3 ones are 3, 3 fives are 15. Then again 3 5 15 and 5 to 1. Right, so 45 can be written as 3 square into 5, which is not equal to 2 to the power m into 5 to the power n, which was our basic condition for a terminating number. That means 3 upon 45 is non-terminating and repeating rational number. Right? Similarly, the next question was 45 upon 120. So first of all, we can find the factors of this. These are 5 9 45 and 5 to 10, and then 5 4 20. Right, then 3 3 9 3 8 24. In that case now we have 3 upon 8. Now the denominator 8 can be expressed as 2 to the power 3, and so we can write it like 2 to the power 3 into 5 to the power 0. As you know very well that any number to the power 0 is always 1. So this will be 2 to the power 3, 5 to the power 0, and thus it can be represented in the form of 2 to the power m into 5 to the power n, and so this is terminating rational number. Okay. Next question was 32 upon 6250. 32 upon 6250. We can break it as 2 1, 2 6 are 12, 2 3 are 6, 2 1 are 2, 2 2 are 4, 2 5 are 10. So this will be 16 upon 3 1 2 5. Now we can take factors of 3 1 2 5. This is 5 6 30, 5 2 10, 5 5 25, and then we can directly go ahead, and that is 25 25. So we can represent it as this 3125 can be represented as 5 into 5 square into 5 square, and finally we can represent it as 5 to the power 5 into 2 to the power 0, which is actually equal to 2 to the power m into 5 to the power n, and so this is a terminating number. Right, I hope You guys are getting the point? Now, let's move to the next question. This is 67 upon 40, right? Now take the denominator 40 and let's try to figure out the factors for the same. 20 to 5, 10. This is 5. Now, this 40 can be represented as 2 to the power 3 into 5 to the power 0. So, again, this is equal to 2 to the power n into 5 to the power n. So, that's why this is a terminating number. Next one, this is 76 upon 90. Now take 90, that is the denominator. And before that, what we can do is like we can check it out, like if we can do this 2 3 are 6, 2 8 are 16, and 45. So now we have a number 38 upon 45, and the denominator is 45, and so 313, 35, 15, 3, and 1. So we can write this 45 as 3 square into 5, which is not equal to 2 to the power m into 5 to the power n, and so this is non-terminating and repeating rational number. Right? I hope the point is clear to all of you. Now moving on to the next question. That is question number 2. Under this, you are supposed to represent a couple of numbers into rational numbers. As a rational number, then you are given some decimal numbers and you are supposed to represent them as a rational number. And I told you that if you have number like 2.4 in bracket, this is same as 2.4 bar. Okay. Now let x equals to 2.4 bar, and so this x equals to 2.444 and so on, right? And similarly, this 10x equals to 24.444 and so on, right? Now let's say this is equation number 1, this is equation number 2, and subtract equation number 1 from equation number 2, you will get 9x equal to 22, and so x will be equal to 22 upon 9. Finally, we can say that this 2.4 bar will be equal to 22 upon 9. Okay, moving on to the next question. That is 0.24 that represents 0.24 bar. Okay. Now let x equals to 0.24 bar or x equals to 0.2424 and so on. Alright. Now let's put 100x. Why? Because I want this 0.24 at the decimal side only. That's why I'm multiplying it by 100. So this is 24.2424 up to infinity. Right? This is equation number 1. This is equation number 2. Now subtract equation number 1 from equation number 2. What you'll get? You'll get 99x equal to 24, and so this x equals to 24 upon 99, and this 0.24 bar equal to 24 upon 99. Alright, moving on to the next point, next question, that is C. This is 0.12, and this indicates 0.1, 2, 2, 2, and so on. Now again, let x equal to 0.1, 2, 2, 2, and so on. Right? Now, this 10x, this will be equal to 1.222, and so on. Right? And 100x will be equal to 12.22. So now after decimal we've got a repeating number in both the equations. So let's say this is equation number 1, this is equation number 2. Now subtract first equation from the second one, you will get 90x equals to 11. And so this x will be equal to 11 upon 90, and so this 0.12 bar equals to 11 upon 90, right? Then we have 2.24, right? Which can be written as 2.24 bar. Now let x equal to 2.2444 and up to infinity. Now 10x equal to 22.444 up to infinity, and 100x equal to 224.444 and up to infinity. Now this is equation number 1. This is equation number 2. Now subtract first equation from second one, you'll get 90x. This will be equal to 224 minus 22. That is 202. Right? And so this x will be equal to 202 upon 90. And so this 2.24 bar, this will be equal to 202 upon 90. And that's the final answer. In the same fashion, let's check out for the next question. The next question is 0.365 bar. Right? This is question number E. Again, let x equals to 0.365 bar. Alright. Now 1000x will be equal to 365.365 bar. I hope now you are able to solve it up. Now subtracting first from second, that will be 999x will be equal to 365, and so this x will be equal to 365 upon 999, and so 0.365 bar will be equal to 365 upon 999. Right? So this is how you are supposed to solve these set of problems. The next question was you have to prove under root 2 to be irrational. Right? So now let's discuss that particular set of problems. Is how you will prove under root 2 to be irrational. Now, before moving ahead, let us assume that root 2 is rational number. Let root 2 is rational. Okay, that means it can be represented in the form of p by q. So this root 2 can be represented in the form of, let's say, p by q, or any number you can take it as a upon b. Alright. Now, this a and b have no common factor other than 1. We can clearly mention this like a and b can have no common factor other than 1. Right? Now, we can square both sides. That means root 2 can be squared, and this will be equal to a square upon b square. And so, this 2 will be equal to a square upon b square. And so, this a square, this will be equal to 2 times of b square. Right? Now, it can be clearly seen here that 2 can divide 2b square, right? So, this implies that 2 can divide a square, This implies that 2 can divide A also, right? That means 2 is a common factor between A and this B square, A square and B square. Now, let's say A is considered to be equal to 2C, where C is some random integer, right? Again, if we square that and put this value over here, right? That means instead of A, I put 2C, so this will become 4C square equal to 2B square, right? And that clearly says that B square equal to 2C square, right? Now we can see that 2 can divide 2C square. This implies that 2 can divide B square, and this further implies that 2 can divide B as well, right? Now we can see here that in this case 2 can divide A and 2 can divide B, but this contradicts our decision that A and B cannot have common factor other than 1, right? But here we have observed that 2 is a factor between A and B. That means this decision has been contradicted. It means root 2 is not a rational number. This shows that root 2 is a rational number. Alright. Moving on to the next question. The next question was we have to prove 5 plus 3 root 2 as a rational number. So 5 plus 3 root 2 is supposed to be proved as a rational number. So now let's go ahead on this point. Let's say 5 plus 3 root 2 is a rational number. Let us assume that. So let me write it for you. Let 5 plus 3 root 2, this is a rational number. Okay? That means 5 plus 3 root 2, this is 3 root 2 equal to A upon B minus 5, right? Can be done. Now, another important point is A upon B, and again, just like another rational number, like A and B have no common factor other than 1, right? Now, let's move ahead. This root 2, this can be equal to 1 upon 3 A upon B minus 5, right? So this 2, this will be a upon 3b minus 5 upon 3. Now, we know very well that in these cases, this 5 upon 3, this is a rational number, right? A upon 3b, this is also a rational number, right? So in that case, A upon 3b minus 5 upon 3, if we complete it, it will itself be a rational number, right? So this says that root 2 is also equal to rational number. But since we have already proved that root 2 is an irrational number, right? So this contradicts our decision. That simply means like since root 2 can never be a rational number, so this contradicts our decision that 5 plus 3 root 2 is a rational number. So this implies that 5 plus 3 root 2 is irrational number, right? I hope the concept is clear to all of you. Have a nice time and take care of yourself. Bye bye.